Besides derivatives, integration is also one of the most important parts of calculus that you ever learn. So what is an integral? To say what is an integral? Well, to first understand what is an integral, we must understand what a derivative is. Just to recall, a derivative, let me use a different color here. A derivative is used to find the slope or tangent of a curve, right? Or a function, or you can say a function, right? And usually denoted as dy dx, or in some cases, like if we have f of x as a function, we take f prime x, right? Now that is what a derivative is. And just for an example, let's just recall that, let's say the derivative of x squared equal to 2x, and the derivative of let's say 4x to the power of 5 is equal to 20, bring the 5 down, 5 times 4, 20, x power 4. That is the power rule of the derivative, just to recall. Right. Now, an integral, on the other hand, is an antiderivative. What does it mean? This means that it's the opposite of a derivative. And it's usually denoted as using the integral sign here. And in this case, let me elaborate more on what an antiderivative is. So let's say we have been given the function f prime x. Once f prime x, which is the derivative of the function f of x. Now, if we want to actually find the original function, we take the integral of f prime x in terms of dx, and we will get f of x. So this is basically what it means to integrate a function. This means that we reverse the original derivative. Okay, let me depict it in a more simple way. Let's say we have a function. This is the set of f of x, and this is the set of f prime x. We use the derivative to get this, and then we use an integral to get back to this. And that's a very simple and easy way to understand it. Now, given that you know this, what are some of the integral rules, right? So let's start off with the most basic power rule, right? Let us do it in a way that we compare derivatives to integrals, right? Now, let us say that we have the derivative of x squared. The derivative of x squared, after you equals to x. That is the power rule. For integral, it's quite simple. Let's say we have 2x. Integral of 2x, the power rule, once you integrate it, is equal to 2x. So that this is 2x to the power of 1, right? So if we take this power of 1 plus 1, then divide by 1 plus 1, which is the top part here, right? And we get 2x squared divided by 2, and therefore we get x squared. Quite simple, right? And well, moving on, let's say we have the derivative of e to the power of 2x. Well, you remember the exponential rule of differentiating exponentials. What we get is we copy e2x multiplied by the derivative of the top part of the power, which is 2, and therefore we get 2e2x. Now, same applies to the integral. Let's say we have 2e power 2 of 2x, and we integrate it. We will get, first we isolate the constant, then we take 2 multiplied by e to the power of 2x, and then we divide by 2 instead of multiplying by 2, and then we will get e to the power of 2x. Moving on, let's say we have the derivative of ln x, natural log of x, which is naturally 1 over x. As for our integral here, let's say we have 1 over x, pardon me, the wrong color, 1 over x. Once we integrate it, we get ln x. Alright, now, following these basic rules of integration first, let us solve some simple questions. We have the integral of negative 24x power 5 dx. First of all, remember that we have a constant multiplier which we can take out. So negative 24, the integral of x5 dx. Now, remember the power rule. So we get negative 24 multiplied by x power 6, because plus 1, 5 plus 1, 6, and divide by 6. And always remember, for indefinite integrals where we don't have an upper and lower limit, in this sense, maybe you've seen the integral from 0 to 1 of a function, right? Negative 24x5 dx, that is the definite integral. And if there isn't any, then it's an indefinite integral. And always remember, for an indefinite integral, we always add a constant at the back. Because, remember, the integral is the antiderivative of a function. Let's say we differentiate a function. Let's say we differentiate a function 2x plus 5. Our dy dx, our differentiated is 2. So once we get it back, once we integrate 2 dx, which we always get 2x, but since there's a 5, we don't know whether it's a 5, it could be a 10, we just add a constant, c. Alright, back to this question. Negative 24 divided by 6, negative 4, x power 6 plus c. And that is your final answer. Right, moving on. Right, okay, now this may seem a bit complex to you, but I suggest you giving it a go. And assuming that you have given it a go, let us continue. So, what a simple way to do is to separate it, right? So, remember, we can separate 2x power 4 divided by x3 dx minus the integral of x divided by x power 3 dx, right? We just separate the function, right? We take this, we take the first part, and we take the second part. It's that simple. Right, now we can simplify 2x dx minus x power of negative 2 dx, and then what we get, 2 multiplied by x power squared divided by 2 minus x power negative 1 divided by negative 1 plus c. Or remember the plus c at the back. And then finally, once we simplify, we get x squared plus x power negative 1 plus c. Or you can also write it as x squared plus 1 over x plus c. Doesn't matter, both are correct. Alright? Now, moving on. Right. The same applies to, we have an exponential here, and the same rule applies. right? So we want to separate it first. So we get x squared dx divided by x squared dx minus the integral of 2x divided by x squared, I get dx. Now you will notice in this case, what happens is you can simplify it first, ex dx minus integral of 2 over x dx. Right, in this case, we want to find the integral. Remember that the integral of e of x, well, it's basically just e power x divided by 1. Since x is the power, since x, the derivative of x is 1, minus, remember that 1 over x is ln of x, but 2 over x, well, remember, okay, let me write on the side tangent here, that the derivative, let's say we have 2 ln x, the derivative of this equals to 2 multiply 1 over x, which is 2 over x. And therefore, if we get back here, we get 2 ln x. And in this case, we get 2 ln x plus c. And then simplify e of x minus 2 ln x plus c. Right? If always notice that if the denominator below is just x, we can always try to simplify, and once we integrate it, we will get the natural log of x. Alright, moving on to the last question. Now in this case, we have a term du instead of dx, and it applies exactly the same regardless whether it's dt, du, dv, it doesn't matter. It's the same meaning. Just remember the change in terms of the, just use the right terms, right? If it uses u, then you change everything to u. So in this case, we also separate it. Remember 2 over u plus integral of 3u over u du, in this case du also. So you get 2 over u, and you always remember 2 over u is the same as 2 over x. So with that, we get 2 ln 2 natural log of u plus, well, the integral of 3 du, well, we get 2 ln u plus 3u over 1 plus c. Simplify it, we get 2 ln u plus 3u plus c. And that is your final answer. In the following video, I will explain more on more integration concepts and to solve even more complex integrals. If you have any questions, make sure to ask them down below, and I will try my best to help.